3 billion years ago, Earth has no green forests, no blue sky, no vida de sun. Under your feet, volcanic rock is still hot enough to bend the air. Ahead, a dark purple ocean hits a world that is not finished yet. Above it all hangs a thick, poisonous atmosphere, swallowing sunlight before it reaches the ground. There is no living creature here to look up. Not yet. Then, in deep space, a point appears. It grows into a rock the size of a city. It is moving 20 times faster than a bullet. At that speed, Earth gets no warning, only impact. The trail leads to Western Australia, into a desert of redstone. This is the Pilbara region, one of the oldest surviving windows into Earth's deep past. Inside it lies North Pole Dome. Australian researchers from Curtin University in Western Australia have confirmed the claim. North Pole Dome is the oldest known trace of a meteor impact on our planet. Its age is 3 billion years. That is 200 million years older than the previous record holder, Varajärvi in Finland. But this discovery is not just a new number in a textbook. It touches the oldest question on Earth. How did life begin at all? Finding evidence this ancient should be almost impossible. Earth does not keep its oldest wounds easily. Continents drift. Tectonic plates collide. Volcanoes melt old rock into new rock. Oceans swallow land, then raise it again millions of years later. A crater older than 2 billion years is usually erased like a footprint after the tide. Pilbara is different. It is a rare fragment of ancient protocontinent, not fully torn apart for almost 3.5 billion years. Its rock layers lie like pages in a giant book. Not crumpled, not remelted, not fully erased. On a ridge 300 meters above the desert plain, geologists found the clue. It was not a perfect circle visible from space. The evidence was hidden inside the rock. They found impact breccias. This rock forms when a meteor impact shatters surrounding stone into fragments. Then pressure of millions of atmospheres welds those fragments together in an instant. Ordinary weathering cannot do this. Neither can a normal earthly process. Then came the microscopic spheres. Tiny droplets of molten quartz, frozen inside ancient stone. They could only form above 2,000 degrees. No local volcano explains that signature. This is the fingerprint of a cosmic strike. Now imagine the day itself. A meteorite 10 to 15 kilometers wide enters the young atmosphere. In seconds, it punches through the gas shell of early Earth. Then it hits the Pilbara protocontinent. The explosion releases about 10 billion megatons of TNT. That is 1 million times stronger than the most powerful nuclear bomb ever detonated on Earth. The ground melts. A crater almost 100 kilometers across opens in the crust. A column of incandescent rock rises hundreds of kilometers into the sky. Fragments fall back across the planet as a rain of hot stone. Within 1,000 kilometers, shallow ocean water boils. If large oceans existed then, tsunamis hundreds of meters high would have crossed the world. Any coastline would have been erased. Trillions of tons of dust, steam, and carbon dioxide rise into the air. Sunlight disappears completely. A cosmic winter begins, not for months, for centuries. And yet, the planet does not die. It changes. Until recently, many scientists imagined early Earth as a quiet world slowly cooling. North Pole Dome suggests something more violent. 3 billion years ago, cosmic collisions may have been part of planetary life. Each impact destroyed, but each impact also rewrote ocean and atmospheric chemistry. The strike pulled minerals from deep inside Earth. Phosphorus, iron, carbon, the exact ingredients needed for the first organic molecules. The hot cracks left by the blast became giant hydrothermal vents. Around them were stable heat, constant energy, and concentrated chemistry. That is why one hypothesis now feels so unsettling. Cosmic impacts may not have only threatened early life. They may have created the incubators where life could begin. The oldest traces of life are found in rocks about 3.4 billion years old. They come from the same Pilbara region. The North Pole dome impact happened only 100 million years later. In geology, that is not a long silence. Perhaps after the catastrophe, simple microorganisms found new places to spread. Perhaps the wound became a cradle. North Pole Dome is not just a crater. It may be one edge of life's nursery on Earth. Today, the rocks of Pilbara seem silent. But beneath each step lies 3 billion years of violence. All continents from that time are gone. Any life that existed then has vanished beyond recognition. But this small scar survived. It reminds us that Earth's history is not a calm river. It is a record of cosmic meetings, disasters, and impossible beginnings. Geologists already suspect Pilbara may hide even older impact traces. Maybe life began even earlier, under an even greater cosmic event. So tell me in the comments, was this impact destruction or birth? And if you want more mysteries where science meets the unknown Earth, subscribe and leave a like. Because sometimes the greatest secret does not begin in the sky. Sometimes it is already under our feet.